Conceptual questions. Question. Make list of similarities and differences between the motor effect and electromagnetic induction in a moving wire, the dynamo effect. When we talk about similarities, then we know that motor effect and electromagnetic induction both are used for conversion of energy from one form to another form, and both use magnetic field. They require some magnetic field. When we talk about dissimilarities between motor effect and electromagnetic induction, then we know that electromagnetic induction is used to convert the mechanical energy into electrical energy, but the motor effect is used to convert the electrical energy into mechanical energy. In electromagnetic induction, the input is provided by some mechanical mean, because in electromagnetic induction, mechanical energy is converted into electrical energy, and in motor effect, the electrical energy is converted into mechanical energy. So in motor, the input is some electric source. In electromagnetic induction, the electrical output is used to operate some load. In motor, the torque is used to rotate the load. As we have discussed in previous lecture, that back EMF depends upon the rotation of motor. When we just start the motor, at that time back EMF is 0. With increase in the speed of motor, back EMF also increases, and we know that back EMF always opposes the applied potential V, and current I can be written as I is equals to applied potential difference minus back EMF divided by load resistance. So from this formula we can see that this back EMF is always less than the applied potential difference. So we have back EMF that is smaller than applied potential difference. Question. Why does back EMF tend to decrease as the rate of doing work increases? When we connect the motor with external load, for example fan or lamp or any device, then rate of doing of work increases. Due to that, speed of rotation of coil also decreases, and we know that there will be decrease in change in magnetic flux. And from Faraday's law, we know that rate of change of magnetic flux is directly proportional to induced EMF. And here induced EMF is back EMF. So when rate of change of magnetic flux decreases, so back EMF also decreases. Question. Give the formula for flux linkage in terms of angular orientation. As we know that flux linkage is equals to N number of turns of coil into phi flux, and we have phi is equals to BA cos theta, putting the value of phi in this equation, and we know that theta is equals to omega t. Theta is angular displacement, omega is angular velocity, so theta is equals to omega t. Putting the value of theta and phi in this equation, we get flux linkage is equals to N number of turns of coil, A area of coil, B magnetic flux density into cos omega t. So this formula of flux linkage is in terms of angular orientation, because it contains omega, that is angular velocity, and that represents the angular orientation. Question. Explain the eddy current in terms of Lenz law. Also, by drawing a suitable diagram, show the direction of eddy current and the polarity produced in the sheet as a result of magnetic field. Suppose a cylinder that is rotating in a magnetic field, and due to its rotation there will be change in magnetic field, change in magnetic flux through this cylinder, and due to change in magnetic flux there will be induced current through this cylinder, and that induced current in the cylinder is known as eddy current because that is swirling in this conductor. And according to Lenz's law, the direction of induced current is such that it opposes the cause that has induced it, and here the cause is change in magnetic flux that has induced this current or eddy current. So this induced current or eddy current will oppose the change in magnetic flux. Due to that, there will be a force that will oppose the rotation of this cylinder, and due to that force there will be heating effect, and we can reduce this heating effect or this eddy currents by using stake of coins and the insulation between these stake of coins. Question: how electromagnetic brake work? Explain. Electromagnetic brake work on the principle of electromagnetism. We apply magnetic flux perpendicularly to the direction of rotation of wheel, and there will be eddy current, and eddy current will flow in opposite direction of the wheel. Due to this, there will be a force to oppose the rotation of wheel, and by the help of this phenomena there will be reduction in speed of wheel and it will be slowed down, and finally it will be stopped. So by this we achieve the frictionless braking, which help us to increase the lifespan, reliability, and decrease the maintenance cost. So that's why it is the future of automobiles. Question: a bar magnet is dropped inside a long vertical tube. If it is made of metal, the magnet quickly approaches a terminal speed. But if the tube is made of cardboard, the magnet falls with constant acceleration. Explain why the magnet falls differently in the metal tube than it does in the cardboard tube. We know the phenomena of electromagnetic induction when a bar magnet is dropped inside a hollow metallic tube. So there will be eddy current produced in the metal tube, and due to that eddy current, opposing force will be applied. According to Lenz's law, the eddy current will oppose the change in flux. So that's why that opposing force will be soon equal to the weight of magnet, and that will achieve terminal velocity or uniform velocity. But when magnet is dropped inside a cardboard, so there will be no induced EMF or no induced current. So there will be no opposing force experienced by magnet, so it will continue to fall with constant acceleration. Question: the transformer suffers from eddy current loss. Explain how eddy currents arise. State the features of transformer designed to minimize eddy currents. We have discussed this question in previous lecture, lecture number 6, electromagnetic induction. Go through that lecture for explanation of this question. Question: analyze information to explain how induction is used in cooktops and electric ranges. Actually, we use coil beneath the glass ceramic cooktops, and we apply alternating current to that coil. Due to alternating current, there will be change in magnetic flux through that coil, and change in magnetic flux through that coil will produce eddy current in metal pot, and metal pots will be heated due to that eddy current, because eddy current generates extra heat to metal pots, and that metal pots will heat up the food. Question: explain what is meant by the term back EMF in any electric motor operation. We have discussed this topic back EMF in lecture number 5, electromagnetic induction. Go through that lecture for explanation of this question. Question. Explain why it is an advantage for the armature to rotate in a radial magnetic field rather than a uniform magnetic field. When we use radial magnetic field, so coil rotates within the magnetic field, so that's why we use radial magnetic field. And pole pieces of magnet are made concave to make field radial. So due to concave pole pieces of magnet, we have a radial magnetic field and coil rotates within the magnetic field, and the plane of coil is always parallel to the field, and we have theta is equals to 0 degree, so we get maximum torque